So my training is called What Even is Tech Quality and Why Should I Care? It's quite a long presentation. So what I'm going to try and do is zoom through a bit of theory to start off with. So points 1 and 2 are a bit of theory on how I see the way that we build tech quality awareness and like kind of how I did it in the first sort of 6 to 9 months of my time at Theodo. And then part 2, like how can we do this better in sort of my view? And then I want to get onto the main section, which is kind of my model of what tech quality is that I wanted to share with you guys. So yeah, building our tech quality frameworks. So as kind of like a junior dev, a typical thing that you might do, which a place that you might start to develop a tech quality framework is through submitting lots of code reviews. So you might submit this pull request. It's something that I did about this time last year. It's not a very nice pull request, and your architect might leave some comments, some very helpful comments. If anyone can send me like a message after the training as to who left all these poo emojis on my review, then you win a prize. But what I start to do as a junior dev is I start to pick out very concrete examples of things that went wrong in this pull request. So, so I take out these concrete examples, and I won't go through all of them, but you can see like the top one is like using as keyword, and the bottom one is, for example, like not using an index as a label. Like I start to associate these with like things that kind of could be improved in my code. And like from my perspective at the minute, it's quite easy to see like the reason why behind some of these. Like the immediate reason is like type safety. There are some other rules here which I can kind of extrapolate from these specific concrete examples. So like not using magic numbers, try not to duplicate code, writing easy to understand code, giving meaningful names to your variables. So I start to build up a pattern of some principles that I can use, and I can apply those to the future pull requests that I submit. And I kind of noticed that some of these principles are related. So like having meaningful names and like not using magic numbers all kind of falls under the umbrella of like, let's write code that's easy to understand. And these are all like obviously related to the concrete examples that I've built up. And these concrete examples don't need to be, it doesn't need to be in a code review. It could just be chatting to your architect. It could be you've been on a personal project and you found that this one thing was particularly painful. And we start to build this model up. So having a framework of tech quality is like really important. It's really, in my view, like one of the only ways to make like rational decisions about tech is you have some sort of value structure and you can make decisions based on these principles. And the question really is like, how do we build this framework up for ourselves as quickly as possible? So taking a look at, the tech quality framework that I've derived just from this one code review, I might say something like, okay, like writing easy to understand code is kind of like how I think of tech quality at the minute. So I'm just going to focus on doing that. I suppose like the problem is, my architect who gave me all those comments on the code review probably has a significantly broader view of what tech quality is. And I'm only exposed to a certain amount of that model, that framework that they have through those concrete examples that I've submitted to them in that pull request. So this is all an example of like bottom-up learning. So what does that mean? It means that I take lots of concrete examples from like code reviews, from talking to your architect, and like working on personal projects. And I start to gain more and more of these concrete examples and build these up into like abstract principles, which then I can apply, across to different technologies, different frameworks. I suppose there are some drawbacks to purely deriving your framework this way. The first one is you need lots of examples, so many concrete examples, and a lot of time like actively reflecting on these concrete examples in order to derive those principles. So one of those principles might be easy to understand code. It's impossible to derive other valuable principles which might fit under tech quality, but do not necessarily relate to those concrete examples. So in the one code review that I had sort of easy to understand code as the main theme, but testing our code is also a sort of unrelated principle, which a lot of us would agree like falls under tech quality. And I would have no way of deriving that we should be testing our code based on that single code review. And then the other thing is, it's really, in my view, it's like really impossible to compare or make comparisons between different principles. So which one do I care about more? Like, should I care about the implementation that focuses more on security, or should I care about the implementation that focuses more on sustainability, for instance? So I have two suggestions on like ways that we can like progress faster than this sort of bottom-up approach. The first one is it's almost like a hack, and I put it in here because it's just been so useful for me. After sort of like 9 months at Theodo, I started reading a lot more books, and there are people out there with like 30 years of experience who have already done all this bottom-up deriving of these like really great principles that you can follow. And they will just explain to you in these books, like, this is the model of tech quality that you should maybe consider. And you can just start from that framework, see what works for you, and build up some concrete examples which kind of fit within that framework. And the second thing is basically what I want to focus on for the rest of the presentation, which is knowing the goal. So does anyone recognize where this little thing is from? Command and control versus orient and support. Yes, we got the newest joiner answering the question. So in Lean or the TPS, we've got this idea of like command and control versus orient and support. And usually these are like management styles. But the idea with orient and support is that you clarify a goal for someone, and then you trust that they're a smart person and they're going to come up with smart ways of reaching that goal. So an example would be command and control, me as the architect just saying, okay, don't use the as keyword in TypeScript, it's bad. Whereas orient and support, which is what we should be doing as architects, is we clarify the goal, which is we're trying to reduce the number of bugs in production, and type safety helps us to do this. And using the as keyword removes type safety. And just changing the way that we approach setting a goal. Now that I know what the goal is of like this comment on this one pull request, I know the goal is reduce the number of bugs in production, and I can actually look for other ways of doing this without directly being told what they are. So from that goal, I can derive other things. So I know type safety is important, but I can also derive things like, oh, if we want to reduce the number of bugs in production, maybe we want some automated tests, for example, that should reduce the number of bugs in production. And I can suggest this to my architect and say, do you think I should write an automated test for this? And I think the way that I'm framing this is a sort of combined bottom-up and top-down learning. So we provide you a sort of goal or a framework to work within, and you can build up those concrete examples. That just happens through brute force of like your everyday job. You're submitting pull requests, you're getting that feedback. You're also learning, okay, this worked, this was painful, so I'm not going to do this in the future. But also you can directly connect those to what the goal is. So just a summary of the theory before I jump back into what I actually think my framework of tech quality is. So like mostly, or like in my experience, in my first sort of 6 to 9 months of working at Theodo, I mostly work with sort of bottom-up learning, building up these abstract principles about tech quality for myself. But it can be slow because it's costly to build up this model of useful abstractions. And you can't derive sort of other unrelated principles which might help us without having those concrete examples. And also, you have no value structure to like make decisions about which things you should care about more than other things. And so my suggestions are we can learn faster by learning the value systems that like experts have already derived for us, and also like defining a clear goal to show us like what is good, like what is the thing that we're aiming for, so that we can learn via like a combination of like bottom up and top down learning. So I suppose now on is we get into the kind of like the juicy bit is kind of what do I think the framework for tech quality should be. And I suppose like the broad question here is like, what is the goal of a software engineer? And TPS, the Toyota Production System, kind of offers a similar framework, but the framework is more for generating value. So at Theodo, kind of this, in my mind, this is the goal, is like the goal is customer satisfaction. It sits at the top of the Toyota house. And the how of like, how do we achieve customer satisfaction is everything below that. So it's just in time and Jidoka, which is, speed and quality essentially. And so my premise for how I build up my framework for tech quality is that my goal is to deliver as much value as possible. It sounds very generic. And the same can also be applied to biz devs as well. Like, I think that is your job as well. But how do we do that? So everything from here on is kind of derived from all the activities that I'm doing are just the things that provide the most value to the client. And there's an interesting thought here, which is if we find a better way of generating more value to our clients that doesn't involve programming, then in my opinion, we should focus on that. So one example of this would be like the architects training the devs, for instance, where I'm not physically there writing code, but I'm supporting the devs so that we can have two people writing code rather than one person writing code. So I suppose this is the main how of our jobs. We generate value by building products that bring people value. It seems like a tautology maybe, but I just want to focus on building products at the minute. And so the important question when we consider like building products that bring value is like, what properties of the products that we build bring value? And I've not come up with this, but through my reading, this kind of seems to be my suggestion, is that value is roughly the multiplication of the behavior of the system and the implementation of the system. So what it does and how it does it. And I've added alpha and beta as like constants, which kind of represent the ratio of how much we care about the behavior versus the implementation. And I'll talk about that in kind of the next slide or a couple of slides later. So defining the behavior of the system. So this is like, what does it allow the user to accomplish? And like, why is this important? Why does it deliver value? Why does it actually deliver value? If it doesn't solve a problem, you're not going to have any users. No one pays for it. Therefore, there's no value. I think that's quite a direct link to not having value. The other part of the equation is the implementation of the system. So that's how was it coded to work? And why is that important? Well, if it has like very low tech quality, you've got a system with very low tech quality, it's really difficult to correct undesirable behavior. So if you can't correct undesirable behavior, soon the requirements will change and your software becomes useless. So just to give you like one example of this, I've got two implementations here of the Hello World. So in Node. So the first one at the top seems quite self-explanatory, just console.logs hello world. The second one, I had to truncate all the characters, but there's a JavaScript is weird video which explains like how this these string of characters like prints out the exact same thing as the top program. And let's imagine that, like, we're working on a project, and this is the piece of software that the client wants. They've got their requirements. It's a program that prints out "Hello World" when you run it. Both of these two programs actually behave identically, but as soon as the requirements change and the PO now says, "Oh, I want a program that now prints out "Hello James," I can change the first one and probably everyone here could just change the first implementation to say "Hello James" quite easily, but I would struggle to change the second implementation at all. And so as soon as the requirements change, the second program delivers no value, and it's been rendered worthless by its implementation. So this is just like a demonstration of how, like, you can write one thing that's easy to change, the implementation is good because it's easy to change, and that delivers value. So I think this is my most controversial slide, maybe. Basically deriving the difference between, or defining better the difference between the behavior of the system and the implementation. So this is, behavior of the system is like, what does it do? What problem does it solve to the user? And this is all stuff that is visible to the user. So anything that the user can detect is part of the behavior of the system in my sort of classification. And the controversial bit is that I put non-functional requirements, which include like the 3S and the 4S in this side of behavior of the system. So that means, like, security is part of the behavior of the system. And the reason why I've classified this is that users can tell the difference between a system with good security or good scalability and one with bad security or bad scalability. Because either if it's got good security, then they're not going to get hacked. And if it's got good scalability, then they don't get patchy service as soon as multiple people start using the service. And also, I like putting non-functional requirements inside the behavior of the system, or like classifying it as part of the behavior, because then it focuses us to negotiate with our non-technical stakeholders on on these as requirements. So it almost becomes like a first-class citizen of things that we need to talk to our clients about and say, hey, like, what level of security does this need? What level of scalability? And so on and so forth for all the non-functional requirements. And obviously, non-functional requirements change from system to system as well. So basing my my tech quality model on non-functional requirements will get some inconsistent results. So next, I've got implementation of the system. So the difference is that the user can't tell the difference between two implementations that have the same behavior. So essentially, this is all stuff that is invisible to the user, invisible to non-technical stakeholders. And we don't negotiate, on the other hand, we don't negotiate the implementation of the system with non-technical stakeholders. It's our job as technical people to come to them and say, like, this is the best implementation given the requirements that you've just given me. Because we're the experts. You wouldn't ask, the analogy is you wouldn't ask a plumber, or you wouldn't expect a plumber to ask you how to fix the pipes. You would just say, I need my plumbing fixing, do it. And you would trust them as the technical person to fix your plumbing. So just to summarize, behavior of the system is everything that's visible to the users, and this improves with product quality, or what I'm calling product quality. And the implementation of the system, which is invisible to users, improves with tech quality. So now we're getting down to a definition of tech quality that is actually a bit more tangible. So the shocking thing here is the 4S is not the same as tech quality. So I started drawing out a value framework from this. So your job is to generate value. And how do we do that? We build products that bring value. And this is kind of split into two things. So the two things that of the products that we're building, quality or like value is brought by optimal behavior and optimal implementation. So optimal behavior improves with product quality, and optimal implementation improves with tech quality. So I'm now going to focus on what does it mean to have like an optimal implementation. I've got a tentative suggestion of like product quality versus tech quality. So product quality is essentially like how well does the system solve the problem for a user right now? And tech quality is about how easy is the system to change so that it can solve the problems that the user is going to have tomorrow. And that's kind of the distinction. So if we take this as a thought experiment, so the question is, like, which one is more valuable? Which one should I care about more? Should I care more about product quality or tech quality? And it's kind of outlined with this thought experiment. So if I have a program that behaves perfectly, but is impossible to change, so it meets all the requirements, but I cannot change that program because it is so complex that it's just so difficult to change, then it'll work now, but it won't work when the requirements change. And I won't be able to make it work, and the program will become useless. On the other hand, you might have a program which doesn't behave correctly now. It doesn't meet all of the requirements, or it could even not meet any of the requirements. But if it's easy to change, then I can fix it quite easily. And also, I can keep it working as the requirements change. And so the program just can like perpetually generate value for our users. And the examples there are, the very, very complex implementation of Hello World is very difficult to change. As soon as we change the requirements, it's generating no more value. And I've got a graph as well to visualize this for you. So this is from Martin Fowler. So on the y-axis, we have cumulative functionality, or like this is like the amount of features that we're giving to the user. And on the x-axis, we have time. So you can see there is a blue line, which represents like high tech quality, or high internal quality, as he calls it. And there is like a brown line that represents low tech quality or low internal quality. And as you can see, this property, like tech quality, allows us to continue to like change the system or create new features at a constant speed. Whereas if you've got low internal quality, the speed quickly starts to drop off, and therefore you can't provide any more value to the users quickly. So kind of a summary of that, like what is the optimal implementation? It has something to do with tolerance to changing requirements. So it's this time-dependent part of like product development. So how do we build systems that are tolerant to change? So this is where all of these principles start to come in. So I won't go through all of them, but you probably know quite a few of them. It's like write readable code that's easy to understand, follow solid principles if you're doing object-oriented programming, or keep it simple, don't repeat yourself. I added do repeat yourself because I found don't repeat yourself doesn't work all the time. The law of Demeter is a cool one, so keeping implementation details hidden. These are all the things that we can learn from reading these kinds of books like Clean Code. But the one thing that they all have in common is they're all in service of keeping our system as malleable as possible. I heard a good thing, like the reason why we call software is because it's soft. If it was difficult to change, we would call it hardware, but because we're trying to make it easy to change, we call it software. So as you can see, we've got the kind of the goal that we're aiming for here in tech quality. And just to broaden it out a bit more, I'll leave you with almost two thoughts. So one, we can use this as sort of like a way to evaluate a solution. So you can ask yourself, like, is this implementation going to enable another engineer to come along and easily change the behavior of the system in the future is kind of a good way of like thinking about things if you're like quite new in the job and you're like, okay, I don't quite know what tech quality is, and there are all these principles, I don't know which one matters more. That's a good starting point. And then also I kind of want to like broaden tolerant to changing requirements a bit more. Like if we are truly focusing on delivering value, we're focusing on like delivering the most value as quickly as possible and continuing to deliver that value. So actually, I think a good one sentence summary is like a good software engineer minimizes the resources required to build and maintain the desired behavior of a system. Minimizing the resources means like lower cost, so therefore more value, and we can deliver the features like quicker. And I just wanted to highlight it's build and maintain. And usually the maintenance, if you write good software, the maintenance period of some software will last way, way longer than the build, the build phase. So kind of maintenance relates to those, tolerance to changing requirements. So I also wrote this slide out so that it's like super clear what I'm finally saying is like the goal for me is to generate value. How do we do this? Is through writing the best possible implementations of systems. How do we do that? By minimizing the resources required to build and maintain the desired behavior of that system. How do we do that? We do that by making the system tolerant to changing requirements. And then how do we do that? By applying coding patterns and other tech quality heuristics like solid design principles. And then how do we do that? Learning, basically. Practice, listening to experts, and hard work. And I suppose that is basically my tech quality framework. And I thought I'd be cheeky and leave the definition of pragmatism. So Google says that pragmatism is an approach that evaluates tech quality in terms of the success of their practical application. So that's in terms of the practical applications of delivering as much value to the user as possible. And that's me. I'm 3 minutes I'm exactly on time. Any questions?